All right, in Unit 6, Lesson 4, we're going to look at exponents now, of course, as a graph, as a function, because once again, that's what Common Core is all about. What do these math things look like when we graph them? So the exponential function is written right here. We have the obvious exponent part, but then we have two other things. We have what's called a base, and what we have is a principal. Now, we'll talk about the principal a little later in the lesson, but right now we're going to look at the base and see some interesting things about what can and cannot happen with a base. Now, you did exponential functions back in 8th grade. So let's look at this. This is the basic exponential function, y equals 2 to the x. So right here we would say the base is 2. There is no, the principal right now is 1, because it could really be written like this. So let's look at 2 to the x. Well, it's kind of simple. 2 to the 0 power is 1. Anything raised to the 0 power is 1. 2 to the first power is 2. 2 squared is 4, and 2 to the third is 8. And remember, when we have negatives, we're just doing the reciprocal. So 2 to the negative 1 is 1/2. 2 to the negative 2, oh, well, 2 squared is 4, so this must be 1/4. And then we can connect all these with a pretty line. And there we have it. Now remember that down here, something is special is happening. This exponential graph will never touch the x-axis. Remember, that was the word, an asymptote. And remember this fine memory?
You can't touch this. You can't touch this. You can't touch this.
Hammer time.
You can't touch this.
All right, so the asymptote is a line that a graph gets very, very close to, but it doesn't touch. So in this case, the asymptote here, we'll make this a little smaller so it fits. So in this case, the asymptote here is the line y equals 0. That's the equation for the x-axis, and this exponential graph will never touch the asymptote y equals 0. How about if we took it and we raised it to a negative power? Well, hopefully now your 8th grade and some of your geometry transformations are going off in your head. Remember what happens when we negate an x value? We flip over the y-axis. Now, I could have done this one of two ways. We want you to learn the shortcut way, which would be this. Okay, I'm going to take this, and I am going to copy all that, paste it all here, drag it over, but then it says I want to flip it over the y-axis, so I'm going to flip left-right. Oh, my dots didn't flip. But that's good. My new equation did flip. And if we can kind of really make it almost perfect, it would look like that. And again, if you didn't want to do that, you would just do your table. So 2 raised to the negative 2 is 4, right? So when I have a negative 2, they're telling me my answer is 4. Looks good. And 2 to the negative 1, they're telling me my answer is 2. So when I put a negative 1 in, my answer is 2. Not bad. The line kind of flipped perfect. And we could keep this going on. 2 can't negate 0, so 2 to the 0 is 1. And then when you have a 2 to the negative and then 1, right, it's a negative exponent, so that means it's 2 to the first, and then we take the reciprocal, 1/2. All right, so take that knowledge a little further right now, and what have I negated here? In essence, I negated the y, because if I divided by a -1, I could rewrite this equation as -y equals 2 to the x. And what happens when we negate the y? You flip over the x-axis. So once again, I could do my chart, x, y, and I'll just pick the easy points to put in. And I'm going to say -2 raised to the -2. Now careful. What they're asking you to do first is take 2 and raise it to the -2. So 2 raised to the -2 is 1/4. And then put the negative sign in front. Likewise, -2 raised to the -1 means I'm going to raise 2 to the -1, which is 1/2, and then negate it. All right, so if I bring back my graph from before, drag it over here, and they want me to flip it over the x-axis. So that means it's going to look like, let's see if I can get this right. Boom, it's going to look like that. All right, our chart over here could prove that. When I put a -2 in, they're telling me my answer is -1/4. And when I put a -1 in, they're telling me my answer is -1/2. Looks good. If I put a 0 in, well, anything to the 0 power is 1, and then we throw the negative in front of it. And that's looking to be good. And then -2 raised to the first, well, 2 to the first is 2, throw a negative in front of it, and boom, that's what I'm getting. Here is the tricky one. And yes, you have to understand the difference between when the negative is outside a number and when the negative is inside brackets and on the number. So if I were to do a chart here, and again, I'm going to pick I'm going to do -3, -2, -1, 0, 1, 2, and 3 to show you what happens. So this says take the number -2. Not like before where it said take the number 2 and then negate your answer. This says take the number -2 and raise it to the -3rd power. Well, -2 cubed is -8, and then since it's the negative exponent, it becomes a fraction. -2 raised to the -2, well, -2 squared is 4, and then the negative exponent tells me to make it into a fraction. -2 to the -1, well, -2 to the first is 2, and then the negative exponent makes it 1/2. Well, sorry, -2 to the first is -2. And then the negative exponent makes it 1/2. -2 to the 0, anything is 1. -2 to the first is -2. -2 squared is 4, and -2 to the third is -8. Now watch what happens when I go to graph these points. All right, when I'm at -3, I'm down here at -1/8. When I'm at -2, I'm up here at 1/4, roughly. When I'm at -1, I'm at -1/2. When I'm at 0, I'm at 1. When I'm at 1, I'm at -2. When I'm at 2, I'm at 4. And when I'm at 3, I'm at -8. This is odd. Yes. And that's going to bring us to a conclusion here. This is not an exponential function. You can't do this and say there's two exponential functions. You can't do this. So we're bouncing up and down because if you notice over here circled in red, it goes negative, positive, negative, positive, negative, positive, negative. And basically, there are a whole bunch of points in between here because when one number is negative, the next number after it is positive. So all these points we didn't graph in between, for example, like negative 2.5 and negative 2.4, well, they're going to go odd, even, odd. They're going to go positive, negative also. This is something called divergent, and you'll learn more about that in calculus. And no, it's not the book. This is a little different because now we have a base and now we have a principal. So I just want to show you that this is what you're going to be spending time on. This is saying, say you start off with 2 of something, and then every time you lose half. And this may bring back some lovely memories to half-life in chemistry. So I'm starting off with 2. So anytime I have a 0, that means 0.5 to the 0 power is 1 times 2 is 2. That means I start off with 2. Now after 1 goes by, I only have half left, right? Because 0.5 to the first is 0.5, half of 2 is 1. Now what happens when I have 2? Well, 0.5 to the second is a quarter, and a quarter of 2 is 0.5. So you can see this is an example that the exponential function is going to be what we call decreasing or decaying. And again, we're going to look at more of these as we go on. And another example of decay is this. This is a graph where we start off with 300 of something, and then every year 85% stays with us. So the decay rate, and again, we'll do more of this later on, is 15%, right? If you decay by 15%, that means what remains is 85%. So if you're going to graph this, you're going to have to use a graph that's not really pre-labeled. You got to look at what your answers are. So you may have to take some time to do a table over here and realize, okay, x and y, if I put 0 in, that means I'm going to have 300 because that's where I start. 0.85 to the 0 power is 1. 1 times 300, 300. After 1 year goes by, or 1 of something goes by, 0.85 to the first means I'm going to have 85% of 300 left. And that is, if I get out my handy dandy calculator, which you're going to hear in the back, I'll have 255 left. Now, if 2 goes by, so that means it's 0.85 squared, and then I'm going to multiply that by 300, it means I'm down to only 216.75 left. And let's put in a 3.85 to the third times by 300 means I'll have 184 point, let's call it 24 left. I'm going to round it. So if you want to graph this, you're going to have to make a scale. I'm going to start here at 300. And then halfway in between is 150, half in between that is 75, and half in between here is 225. And if I were to graph this, okay, at 300, when I'm at 0, I'm at 300. When I'm at 1, I'm at 255. When I'm at 2, I'm at 216. I'm going to have to eyeball it. when I'm at 3, I'm at 184. This is my x, this is my y, and you can see again that this is going to be a decay of some sort because I'm only keeping 85% of what I start with every single time. So basically, this is what we want you to learn about exponential functions. We have a principal, what we start with, and then we have some kind of rate, and that's what the base is. Now, about that base, it always has a positive number for its base. We saw that we couldn't put a negative there, and likewise, we can't put one positive number. B cannot equal 1. I know 1 is a positive number also, but think about it. What's 1 to 1? 1. What's 1 to 2? 1. What's 1 to 3? 1. You're not showing any growth or decay. Once we figure out what that base is, it can either be growth or decline. And if the base over 1, it represents growth. And if the base is between 0 and 1, it represents decay.